All right, so we took x squared and we divided by x and we got x. And then we take x and multiply it by everything on the outside. And so we're going to have x squared and then 5x. And then I put parentheses around it and I subtract. The x squareds cancel. And then I have negative 8x minus 5x, which makes negative 13x. And then I bring down the next number. From there, you do negative 13x divided by x, which is negative 13, and then I stop there. Yes, I should keep going and multiply those and then subtract and get a remainder, but I don't care about the remainder. All we care about is the x term and the constant term. So that is my oblique asymptote, x minus 13. So let's do the same thing for 8, because 8 has an exponent of 2 and an exponent of 1. So the top is larger than the bottom, but they're only one apart. So that means you're going to have an oblique asymptote. So we take the bottom on the outside, the top on the inside, and we go through and divide. So we do 2x squared divided by x, which is 2x. Then we take 2x times x and we get 2x squared. Subtract and we get 0 or nothing. And then we bring down the 7x. So then we do 7x divided by x, which is 7. And then we can stop. That's all I need is the x and the number. So I get y equals 2x plus 7 is the oblique asymptote. Now we're going to apply all this and some other things that we've learned so far into graphing. So what we're going to do is we're going to factor the polynomials. We're going to find intercepts. Then we're going to find asymptotes. And then we're going to put all this onto a graph. And then you can pick points to plug in, or we can look at a graphing calculator. Yeah, we'll see what happens. So as we look at this function, factoring, step 1, the only thing I see is we could factor out a 2 on top. And so that would be my factoring. 2, finding intercepts. It says find x-intercepts, but I think we could also find y-intercepts if you want. So x-intercepts you find by just setting the top equal to 0. So if I set the top equal to 0, the 2 gives me nothing. The x plus 2 gives me negative 2. So that means that I'm going to have a point at negative 2, 0. So I can go ahead and put that on my graph. And if I want to find my y-intercept, it's not my list, but if I want to find my y-intercept, I would plug 0 into the function. So let's just do that. And then here I'm getting 4 over negative 1. So I'm getting negative 4 for the y-intercept. And so that tells me 0, negative 4. And I'm going to put that on my graph as well. So I know some points, which is always helpful in making a graph. 3, we're going to find the vertical asymptote. The vertical asymptote you find by setting the bottom equal to 0. So I'm going to add 1 to the other side, and I get 1. This is a vertical asymptote. So I'm going to go over to x equals 1 and draw a dotted line, a vertical dotted line through 1, which is the vertical asymptote. So the graph is going to approach that dotted line but never touch it. And then we're going to look for horizontal or oblique asymptotes, and we do that by comparing the degrees of the polynomials. So this is degree 1, this is degree 1, they match. And so if they are the same degree, then it's your number in front, and you have a 2 and a 1 in front. So we're going to have a horizontal asymptote at y equals 2. So we're going to go to y equals 2, make a horizontal dotted line. All right, so that's what we have so far. And then we plot all that information. That's step 5. And then 6, we plot some more points. You can either, like it says, go to a graphing calculator and pick some points, or plug them in on your own. So I am looking at this graph, and I've got 2 points on the left side of the asymptote. I want to get another point over here, so I'm going to plug in -1. Then I want some points on the right side of my dotted line, so I'm going to plug in 2, 3, and 4, which are just to the right. If I plug in -1 to the function, so let's look at it, I'm going to have 2 times -1, which is -2 plus 4. So we're getting -2. And then if I plug in -1 here, I get -2. Or wait, I did that wrong. If I plug in -1 up here, I get +2. So I get +2 divided by -2, which is -1. So I've got -1 is at -1. And 3 points, I think, is enough to kind of see the curvature of what's happening over here when we know it's going to approach the dotted lines, so we can see the curve. Over here, I'm plugging in 2, 3, and 4. So if I plug in 2, I get 2 times 2 is 4. 4 plus 4 is 8. If I plug in 2 on the bottom, I get 2 minus 1 is 1. And so here I'm getting 8. When I plug in 2, I get 8. Plot that point. And let's plug in 3. 2 times 3 is 6. And 6 plus 4 is 10. Plug in 3 here. 3 minus 1 is 2. So here I'm getting 5. So for 3, I am getting 5. Put that on the graph. And then plugging in 4. 4 times 2 is 8. 8 plus 4 is 12. And then plug in 4 on the bottom. We get 3. And so we're going to get 12 divided by 3, which is 4. So I'm having 4 is 4. And again, with 3 points, we can kind of see how it's curving. And that'd be a graph of the rational function. All right, let's look at example 2. Step 1, factor. 1, we did. 2, find intercept. So if I set the top equal to 0, then I get x minus 5 equals 0. I'm getting 5. So we've got 5 comma 0 is the x-intercept. And I put that on the graph. If I plug in 0, I'm going to get 0 minus 5 over 0 minus 3, which is 5/3. So if we want to plot that, so that means it's 1 2/3, so we're getting close to 2. And then we want to find our asymptotes for step 3, vertical asymptotes. So set the bottom equal to 0, and you get x equals 3 is your vertical asymptote. So we're going to go to 3 and draw that dotted line. Then step 4, we're looking for horizontal and oblique asymptotes. We have degree 1 over 1, so it's that 1 in front. So we have a horizontal asymptote at y equals 1. And we're going to plot that on the graph. And then we just need to find some more points to plug in. So let's plug in on the left side of my dotted line. I've got 2 and 1, and I already have 0. So 2, 1. Over here, I've got 4, 5, 6. Let's plug in 4 and 6 since we already have 5. So if I plug in 2, I get 2 minus 5, which is -3. And I have 2 minus 3, which is -1. So we're getting 3. So at 2, we're up at 3. So plot that. If I plug in 1, I have 1 minus 5, which is -4. 1 minus 3, which is -2. and so that's going to make positive 2. So 1 is at positive 2. And with those 3 points, you can see how it curves. So it's curving down towards the asymptote and up towards this asymptote. Then I'm going to plug in 4. 4 minus 5 is negative 1. And 4 minus 3 is 1. So we're getting negative 1. So 4 is at negative 1. If I plug in 6, I have 6 minus 5 is 1. 6 minus 3 is 3. So we're getting 1/3 for that. So we just go up a little bit. And so here we are curving towards the asymptotes as well. And that's what your rational function looks like for example 2. Example 3. Let's factor. So we have x minus 1, and we have x plus 2, x minus 2. So that'd be step 1. Step 2, find any intercepts. If I set the top equal to 0, I get 1. So it's going to cross at 1, 0. If I plug in 0, I'm going to get negative 1 over negative 4, which is 1/4. So 0, 1/4. So I've got my intercepts, so I can plot those. So a point at 1 and a point at 1/4 on the y. So we've got those. And then we're going to look for asymptotes. If you set the bottom equal to 0, you have x equals negative 2 and x equals 2. These are your vertical asymptotes. So we're going to plot that. 2 and negative 2. And then we're going to look for horizontal or oblique. The top degree is 1, the bottom degree is 2. So the top is less than the bottom, which means you have a horizontal asymptote at 0. So I put a dotted line at y equals 0. And then we just want to pick some points to plug in. So here I have 3 sections to my graph. I've got left, middle, and right. On the left, let's plug in, I don't know, let's plug in 2 points, I guess. Let's plug in negative 3 and negative 4. In the middle, we already have 2 points. Let's plug in negative 1. And on the right, let's plug in positive 3 and positive 4. So if I plug in negative 4, on top, I'm going to get negative 5. And on the bottom, I'm going to get 16 minus 4, so 12. So I'm getting negative 5/12. So negative 4 is pretty close to the dotted line. If I plug in negative 3, I'm getting negative 4. And I'm getting 9 minus 4, which is 5. So again, I'm getting something not quite negative 1. And so this is going to curve pretty tight to the dotted lines, is what these points are telling me. If I plug in negative 1 up here, I get negative 2. And I get 1 minus 4, so negative 3. So I'm getting a positive 2/3 when I do that. And so this is a weird situation where it actually crosses through the asymptote in the middle. And that sometimes will happen, and it'll happen in the middle near 0. And so that happened this time, where it crossed through the asymptote. It doesn't usually happen. If I plug in 3 on top, I get 3 minus 1, so 2. And if I plug in 3 down here, I get 9 minus 4, which is 5, so 2/5 for 3. So just above the dotted line. And then if I plug in 4, I get 4 minus 1 is 3. And then I get 16 minus 4, which is 12. So I'm getting 1/4 there. So again, these are really close to the dotted line.